Hi everyone. What we're going to be doing today is introducing the idea of mathematical induction. And so, mathematical induction is a proof technique we use to prove statements about things that occur in some sort of sequential step. So, for the basic so called weak induction, the basic idea behind the proof is that there's a statement which is true in some case, and that being true makes each subsequent case true. So, if you follow along the text, you can see the basic outline of this. The first two ideas are first, you establish a base case, and let's just say uh, that's like something like the first case or the zeroth case or something like that. So you show that some statement is true once, and then you prove the inductive step. And what that means is that whenever you have that a statement is true at any time, you prove that it's true for the next step. If you put these two things together, then what you've got is a base case, and then invoking the induction, that forces case 1 to be true, which in turn, again, through the induction, forces case 2 to be true, and so on and so forth. And so, this is the idea you want to keep in your mind when doing these things. You want to um, think of it this way. You want to show that you start some sort of process, and somehow there's a statement that continues to be true that builds up on the previous case has been true, and each time we do this, it continues to be true. Now, um, it's easier to talk about with a concrete example than with something abstract. And so I'm going to do a couple of things. I'm going to lay out an example of something that can be proved with induction. I'm going to talk about the intuition behind this, thinking about that intuitively first, and then we'll write the formal proof of that statement. So let's say um, I have a square. Let's move it down a bit here. Let's say I have a square, and this is a 1 by 1 square, and so we know that 1 is a square number, right? And so let's say I want to get from 1 to the next square. So what I'm going to do is add in 1, 2, 3 more squares with it to get the second square number. So what we have is 1 squared, maybe is 1. And then what we got is next is 1 plus 3. And that gives me the next squared, 2 squared. And I say, all right, now I want to get from that to the next square. What I need to add is 1, 2, 3, 4, 5. Five elements, or 5 little squares around my current square to get to the next step of this. 1 plus 3 plus 5 is 3 squared. And now I want the next level of this, so I get 1, 2, 3, 4, 5, 6, 7 for 1 plus 3 plus 5 plus 7 dot 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 being 4 squared. And at this point, I hope that maybe we can see some sort of pattern building down here in the bottom here. What we have on the right hand side of all of these equations here is sums of consecutively increasing odd numbers, right? We have 1, 1 plus 3, 1 plus 3 plus 5, 1 plus 3 plus 5 plus 7. we're continuously adding on odds. And on the left hand side, we have squares, right? 1 squared, 2 squared, 3 squared, 4 squared. But more importantly, when we think back on this idea of induction, this is what we mean, right? Like we start with something true, like 1 squared being 1, which is clearly true. And the idea we're trying to invoke here is at each step of this, I have to add on 3, I have to add on 5, I have to add on 7. I take the previous case, which I showed to be true, I add on the next odd, and that somehow builds a bigger square. So this is at its heart induction. We take something true, we show that every time I add on or every time I progress to the next step, that preserves the truth of the statement. So it seems like what I want to say here is that the sum of the first n odds, right? Let's label these. That's 1, that's 1, 2, 1, 2, 3, 1, 2, 3, 4. The sum of the first n odds is n squared. So it seems to me that that is the statement that we're trying to prove. So prove n squared is the sum from I equals 1 through n of 2n minus 1. Alright, so again we have our base case. 1 squared is equal to 2, 1 minus 1, which is all 1, so that's checked off, right? And so now we want to assume this, right? We want to assume the kth case of this argument. So I'm going to go ahead here and say we assume this holds when n is k. In other words, that k squared is the sum from I equals 1 through k. Sorry, this should have been an I. 2i minus 1. And now what we want to show that when I progress to the next case, that is going to be the sum from I equals 1 to k plus 1 of 2i minus 1. Right, that's what we want to show now. And so let's think back to what we did here in these squares over here. Every one of these squares here we thought of as a little square adding something else, right? And so that is the heart of the inductive step, and that idea is what's going to translate algebraically into our proof here. So we'll start with k plus 1 squared. And what I want to do is bring back k squared, right? I want to bring it back to the step before. And so is there k squared to be found somewhere here? There is if we expand it, right? Right, k plus 1 squared is, when we follow it out, k squared plus 2k plus 1. And now I want you to think about that statement, right? If I have a k by k squared, the next step of this certainly is a k by 1 rectangle, a k by 1 rectangle, and a 1 by 1 rectangle, right? In other words, 2k plus 1. The previous k squared, that by the inductive hypothesis is the sum from I equals 1 to k of 2I minus 1. So that's that. And what I'm left with is 2k plus 1. Well, two k plus 1 is 2k plus 1 minus 1. We're writing it this way so that it fits the form of the summation here, so I can rewrite this whole thing as the sum from I equals 1 through k plus 1 2I minus 1. And so this part is just kind of technical algebraic semi-manipulation, but all it is capturing the ideas of what's going on this half of the screen, right? What we're basically saying is we start with something that's true, and we build, and we build, and we build, and if we can show this general step, if we can show that we can go from the k case to the k plus first case, then starting with our first case, we can just build that up through all the possible cases. All right, thank you very much. As usual, please let me know if you have any questions. Thank you.